Hello friends, welcome to MindTube, and in this video we are going to cover some basic data structure techniques. And for this video I have opted the sorting algorithm. But before proceeding, I have one question for you, that could you please tell me that which one is the algorithm is used by Collections.sort? Yes, you're right, it's MergeSort. Why it is? Yes, because it's the most fastest one, less complexity. And suppose you have to design your own MergeSort algorithm, how will you do it? So if you will search on Google, then you will come to know that arrays divided into sub arrays, and once it reached to a n level where it can't be divided anymore, and then it's merged. But it doesn't work in this way. We divide it, but we work on subset of array first and then come back to another array. Let's take it very simple. Now your manager gave you this problem that you need to design your own MergeSort algorithm, and ultimately you want this resultant array, the down one, and there is an idea clicked into your mind. What if I'll get two sub arrays which are sorted, and then I will compare first element of one sub array with first element of second sub array. Let's take this as a array and this is B array, and then after comparison, which one is the smaller one will come first in the resultant array. Yes, that's perfect. But right now we don't have this array, we have this array. If we will divide it into two parts, so how we can reach from this thing to that thing? Yes, we have to again divide it to another sub arrays, and then we have to convert this array into this one and this array into this one. So my next slide will explain you how we can proceed further. So in this one, like, we have calculated the midpoint, divided the array into two parts. Now we will put this array into stack, and this array again, like we are working on it, we will divide it into two sub array. Then again this one will be put onto stack, and then we will work on these two. And then here it can't be divided any further, so we will compare it and swap it, and at this level we will reach to the idea that was clicked into your mind, that we need two sub arrays. So in this way you can design your own MergeSort. So let's start the program for this one. So in this program I took the same array that I have explained in my PowerPoint, and before proceeding, let's print it. So there is a convenient method provided by arrays.class, arrays.toString, and we can pass our this array, and then when we will sort it, we will again run this method. Let's try to print it first. So now it's two arrays being displayed, but it's not sorted. For sorting, first of all, we need two methods. One is to break the array into sub arrays, and second is to merge and sort it. So I'll define private static break. I'm not using EAK because it's a keyword in Java, so I'm using break. It's with void return type. So it will be having three arguments: my array itself, and int start, and int end. So we will pass our array. So here I'm passing here. My start element will be 0, my end element will be arrays dot length -1. So far so good. So we have just defined a method which will break my arrays into subpart till n level, and where it can't be further divided anymore. So if this is my recursion condition, so if my start is less than end, then I have to find my midpoint, start plus end, divide by 2, and then I have to divide into two array, A array and B array. So first of all, I need to call my A array with array itself, then my start, and then with Then I have to divide this into B array, which is my mid plus 1, and then end. Now if everything went well, we reached at a point when we can't break it anymore, we will do merge and sort. So for this one we need to define our merge and sort private. It will take these variables in mid. So here I need to pass my and end. That's it. Okay, so my break method is complete. Now we need to concentrate on our merge and sort. Now in merge and sort I need to temporary array which will hold my values, and then as I shown in my slide, we need to compare and then create a resultant array. So int a array is equal to new int, and the length of this array will be mid minus start plus 1, and the other array is b array is equal to new int end minus mid. So we have created two empty arrays. Now we need to fill the data. Just to give you more highlight how it's working. So if you take the example of this step, so we have created a empty two arrays, A array and B array, and then we need to fill the data, and then we will compare it with the first element of B array with the first element of A array, and so on. Then we will create a resultant array. So let's do it. So first of all we need to fill it. Int I is equal to 0, I less than a array dot length I plus plus, and a array I is equal to start plus I. And same for the B array. It's mid plus 1, mid plus I plus 1. So now my data has been filled in these two arrays. Now I need to compare and swap if required and provide a resultant array. So for that it's int I is equal to 0, j is equal to 0, and int k is equal to start. Now while my I is less than a array dot length and b is less than or j is less than my b array dot length, and if my first indexes of a array and b array, if my a array is smaller, if my a array I is less than equal to b array j, then we have to set my first element from a array because it's a smaller one. So in array k is equal to a array I, else I need to get it from the B array. Okay, now here I need to increment I, and here I need to increment j, and in this file I need to increment k. Okay, now this condition will compare the element between two arrays. But what if my array A is finished, means all its element has been consumed, but B is still having array, or take the vice versa, means B is empty now but A is still having array. So we just need to copy all the elements from respective array to my resultant array, because this is already sorted. So now I need to put, while my I is less than, and while my J is less than. So if A is having some elements, copy it directly, and if J has some element, copy it directly. So here we need to do this thing, K plus plus, and here the down one, we need to copy the data from B array and K plus plus. So this is done. Now let's run it. So it's giving me a problem. Let me check. So it's here it's good. Okay, so here I need to put B array. Let's run it again. So here you go. So it works in this way. I hope you like my video. If you like my video, please share it, subscribe my channel, and like my videos. Thanks a lot. Keep watching. I'll see you in next video. Thank you.